Hello, welcome once again to this wonderful tutorial. Little wonder what type of equation is this that contains both a linear equation and quadratic equation. Looking at this, the highest degree of the unknown variables x and y is 1. Hence, this is a linear equation. And at the same time, also looking at this, the highest degree of the unknown variables x and y is 2. So what type of equation of this form, having a linear equation and having a quadratic equation? So how do we solve both of them simultaneously? Wow, it is very simple. I'm going to teach you how to do it. That takes us to the topic of today's simultaneous linear and quadratic equation. Remember that a simultaneous linear and quadratic equation is a pair of equations that contains both a linear equation and a quadratic equation. But in this video, I'm going to show you how to solve both the linear and quadratic equations simultaneously. Let's proceed with the solution of this question. The question says, solve the equations x minus y equal to 2 and x squared plus y squared equal to 52. Let's proceed with this. The first thing we have to do is to say x minus y is equal to 2. We call this equation equation 1. The same thing is applicable here. We have x raised to the power of 2 plus y raised to the power of 2 equal to 52. We also call this equation 2. Let's solve this pair of simultaneous linear and quadratic equation using substitution method. Let's start from equation 1. Then I say from equation 1. And what does equation 1 state? X minus y is equal to 2. This is obviously equation 1. Let me make my x the subject of this given equation such that I have x is equal to 2. The negative y crossing to the right hand side of the equation will change its sign to positive y. Let me then substitute for the value of x into equation 2. So I want to substitute the x value into equation 2. And what is my equation 2? My equation 2 says x squared plus y squared is equal to 52. This is obviously my equation 2. Then I want to substitute the value of x. The value of x is 2 plus y. I want to substitute it in this given equation 2. So wherever I see x in equation 2, I will replace it with 2 plus y. Then I have x now is 2 plus y. 2 plus y. Then because of this square, I have to square it. Then plus y squared equal to 52. All right, let's open up this bracket. And opening up the bracket, this will replicate itself into 2. Into 2 times because of this square here. Then I have plus y squared, and that is equal to 52. Let's multiply out this bracket. 2 multiplied by 2 will give us 4. Then 2 multiplied by y will give us plus 2y. Then plus y multiplied by 2 will give us plus 2y. Then y multiplied by y will give us y raised to the power of 2. Then plus y squared. Plus y squared. And all equal to 52. Okay, let's collect the like terms. Remember that y squared plus y squared will give us 2y squared. So I have 2y squared. Then plus 2y will give us plus 4y. Then that is equal to 52. Then when 4 crosses over to the right hand side of the equation, the sign will change from positive 4 to negative 4. Then I have that 2y squared plus 4y is equal to 52 minus 4 will give us 48. Looking at this equation, it is a quadratic equation, hence we solve quadratically. But before we solve quadratically, let's reduce the coefficient of y squared and coefficient of y and the value 48 to its lowest term, such that when we divide through by 2, we have 2y squared all over 2 plus 4y all over 2 equal to 48 all over 2. And dividing through by 2 so that I will reduce the values to its lowest term, such that 2 will now cancel out 2 and we are left with y squared plus 2 divided itself will give us 1. And how many 2 will go into 4? That is 2. Then we have 2y, and that is equal to 48 divided by 2 will give us 24. So you can see that this is a little bit smaller than what we have here. Let's then arrange this equation to suit our quadratic function. Remember, quadratic equation is an equation of the form ax raised to the power of 2 plus bx plus c equal to 0. So let's also put this equation to have the same look as this general form of quadratic equation. Then I have y raised to the power of 2 plus 2y. Then 24 coming to the left hand side of the equation, we change sign to negative 24, and that is equal to 0. Hence, we can solve this quadratic equation using any method of solving quadratic equation. But for the sake of this video, I shall use factorization method to solve this quadratic equation. Using factorization method, y squared will multiply negative 24. Then we have negative 24y raised to the power of 2. Then we look for two factors that when we multiply them together, we shall have negative 24y raised to the power of 2. Then when we add them together, we shall have positive 2y. Let's take the factors like positive 6y and negative 4y. Obviously, you can see that positive 6y multiplied by negative 4y will give us negative 24y raised to the power of 2. And in the same vein, positive 6y in addition or plus negative 4y will give us positive 2y. Then I now take the highest degree of y, which is y raised to the power of 2. Then I add these two factors. And when I add these two factors, I have plus 6y minus 4y. Then I also take the constant, which is negative 24, and that is equal to 0. Remember, I can group these factors in twos. And grouping it in twos means grouping it into bracket of twos. Then you can factorize further. We have y squared and 6y. Automatically, y is common here and here. We factor out y. In brackets, y squared divided by y will give us y. Then we put our plus. 6y divided by y, remember this is what I mean, 6y divided by y, such that y will cancel out y, we are left with 6. Hence, 6y divided by y, we are left with 6. Then minus the common factor of 4y and 24 is 4. In brackets, 4y divided by 4, this is what I mean, 4y divided by 4, 4 will cancel out 4, and we are left with y, such that we have y here. Then, minus multiplied by minus will give us plus. Then 24 divided by 4 will give us 6. And all is equal to 0. Okay, let's solve further. Since we have y plus 6 and y plus 6, they are the same thing. We take one of each. y plus 6. In brackets, we also have y minus 4, and they are all equal to 0. This is what I did because we have the same terms here. We take one of the terms, then we also have y minus 4, and that is equal to 0. Then, for the product of these two terms to be equal to 0, it is either y plus 6 is equal to 0 or y minus 4 is equal to 0. Remember, when two terms are in each product and it is equal to 0, for this equation to be equal to 0, it is either this term is 0 or this other term is 0. Then when we make y the subject of the formula for this given equation here, we have that y is equal to 6. Crossing over to the right hand side of the equation, we change to negative 6. Or the value of y, when it is made the subject of the formula here, will also be equal to 4. That is adding positive 4 to both sides of the equation. We have that y will be equal to 4, or you say negative 4, crossing over to the right hand side of the equation, we have the value as 4. Hence, our y is equal to negative 6, and our y here also is equal to positive 4. These are the two values of our y. Since we've succeeded in finding the values of y, we also want to find the values of our x, because our two terms consecutively contains x and y. So having found the values of y, we also want to find the values of our x. And what is the values of our x? Let me consider this equation as equation 3. Equation 3 says x is equal to 2 plus y. 2 plus y. This is my equation 3. Then I will then say that when my y is equal to negative 6, automatically, if my y is now negative 6, what will be my x? I will now have that x is equal to 2 plus my y now will be substituted for negative 6. Negative 6. Then I have that x is equal to 2 plus multiplied by minus will give us minus, then 6. And this implies that my x is equal to 2 minus 6 will give us negative 4. So this is the value for the first x. Then let's find the value for the second x. I will then say that when my y is now equal to 4, I've used when y is equal to negative 6. I then want to use when y is equal to 4. So when y is equal to 4, remember that my equation 3 states that my x is equal to 2 plus y, such that I then have that my x is equal to 2 plus, what is my y? My y is now 4, so I substitute it for 4. And this implies that my x is equal to 2 plus 4 will give us 6. So this is the second value of our x. So putting these values of x and the values of y in a coordinate manner or form, we then have, remember, coordinate form is what we call xy axis. This implies that for the first instance, our x is negative 4. So we have negative 4, comma, what is our first y? Our first y is negative 6. We have negative 6. You close the bracket. And the second x value is 6, comma, and the second y value is 4. So this is the final answer for this pair of equation, which is a linear and quadratic equation. Whenever you are given a challenge of this form or a problem of this form, it is very simple to solve. Follow this routine to solve for your answers and find your corresponding values respectively. Thank you for viewing. Thank you for watching. Remember to subscribe to my YouTube channel, Israeli Maths Concept. If you found this video worthwhile, try to reshare this video and let people, especially students, to know about this video. Thank you and see you next time. God bless you. Goodbye.